Hello again, everybody, and welcome to the third video in our proportional reasoning series. Today's topic is going to be scale factors and two-dimensional figures. We should also talk about scale diagrams before we get into the scale factors and everything. A scale is a ratio of measurement in different units. So typically you can see scales on maps or something. So an example might be on a map, let's say there's 1 centimeter would equal, and I'm just going to totally make this up, let's say 100 kilometers. So you can see that we have different units, and what we're trying to do in this example would be taking something that's large and shrinking it down to a map. But you could also have something, if you think biology, they might have a scale too, and they'll say, okay, again, we'll maybe use 1 centimeter, but now it's going to be, geez, I don't know, I'm just going to totally make that up, 0.05 millimeters. So in this case, we'd be trying to create an increase we've taken something that's really small, make it a little bit larger and easier for us to see. So you'd see a lot of that stuff in cells and things like that. A scale diagram uses a scale to create an image that is either a larger or smaller representation of the original. The scale informs a person how much larger or smaller a dimension is in a diagram when compared to real life. Now let's talk about scale factors. A scale factor compares the measurement of one shape to the measurement of a similar shape. The scale factor is displayed as a ratio with both measurements in the same units. So whenever you have the word scale in there, we're going to be talking about at least two shapes, and one's going to be smaller or larger than the other. So a scale diagram, we take something that's small and make it bigger for easier for us to see, or we'd have something that's large and we shrink it down. A scale factor, again, is doing that sort of thing, but usually they're similar in sizes. So you'll have maybe a smaller rectangle with a larger rectangle. And the scale factor is just simply telling you the difference in the size. So to use a scale factor, you simply multiply each linear dimension of a shape by the scale factor. This calculation will produce the length to be used in your diagram or second figure. So let's give you an example of this. So let's say my scale factor is 2. So what that means in this is that it's going to really mean that whatever my new shape is going to be double the size of my original shape. So if I said this is 2 and this is 4, then to make the next shape, and which this is not proportional because I don't have my ruler out or anything, I double everything. So now this would be 4, and the length would now be 8. All right, so that's how your scale factor works. It's simply telling you what you're multiplying each dimension by. And you can have whole number scale factors like 2. You can also have scale factors that are fractions. So you could have, like, say 1/3, which would mean that you're multiplying every dimension by a third. So if I made a square, because I don't have a lot of room here, if I said this was a square and its side length is 9, if I multiply that by a third, I'd make a tinier square, and its side length would be 3. So that's how a scale factor works. It's telling you what to multiply those dimensions by, and it's either going to make a bigger one or a smaller shape. And more on that. A scale factor between 0 and 1 will produce a reduction, a smaller version. So examples of that. Scale factor equaling 0.5. Okay? Obviously I can write that as a fraction as well. Even 0.9, my s didn't show up there. Even 0.9, that's still less than 1, so that's going to give you a reduction. A scale factor larger than 1 will produce an enlargement. So we already showed that. Scale factor, so if I said it was 3 or something like that, and it's okay if it's like 3.1, just something larger than 1. I could be a fraction still too, you guys, so I could give you a different one and just say 3/2. Okay, and you know that that's 1.5, so that's still bigger than 1. Then a scale factor equal to 1 will produce an exact copy of the original. Now that won't happen much in your assignment or anything, but that's how it would work. If you had a scale factor of 1, you're just duplicating the original shape. So scale factor and similarity. So this is where scale factor can get pretty handy, is when you're dealing with similar objects. Now remember, figures are similar when their dimensions are proportional. The proportion that relates the two similar figures is the scale factor. So if there's a common scale factor between two pictures or two shapes, then we know they're similar. So I got some room. Why don't I show you an example? If I said this was 3, this is 6, and this is 7, and then I said this was 6, 14, and 12, and then you start checking the corresponding sides. So you guys would have done this in grade 9. I don't know if you remember doing it, but the corresponding sides, kind of like the sides are in the same position relative to their shapes. So you can see 3 over 6. So if I wrote 3 over 6, I get 0.5. And if I then chose these bottom ones, check out that scale factor, 6 over 12, that's 0.5 as well. Yellow, that's so pretty. All right, scale factor, 7 over 14, that's 0.5. And what that's telling us is that if I call this A and this is B, we could know then that A is 0.5 the size of B. First of all, that's what we know. That's what that scale factor is saying. If you multiply each of those original dimensions by each of B's dimensions by 0.5, you'd get A. And then also it's telling you that because there's a common scale factor, that these are similar objects. Okay. Now scale factors can be used with proportions to determine unknown quantities regarding the two similar figures. So once you know they're similar, we can use proportions to find missing things, and we can use our scale factor to help us in that proportion. A little bit back to the scale factor up top here, everybody. If I were to flip how I wrote those down, because it doesn't matter. If I wrote 3 over 6 over 6 over 3, I'll get a different number. I'll keep doing this real quick. So I'm just flipping these fractions, my comparisons. I got a different number 2 this time, but you can see it's common again, so it still shows that they're similar. And this one's saying, because I put shape B on top, it's just telling you that shape B is double the size of A. So whatever's in your top position here, that's what the scale factor is going to describe how it relates to the other thing. So in that first one, the smaller number is up top. It's telling you that that first shape then is half the size. In my second one, the larger shape is up top and it's telling you it's double the size of the other one. All right, let's keep moving. So scale factor in two-dimensional figures. In general, if the scale factor between two similar figures is A to B, so if you're comparing shape A to shape B, then the ratio of their perimeters is that same number, and the ratio of their areas is you take that scale factor and square it. So it would be A to B squared or A squared, B squared. So I'm going to show you some examples. It's actually a really easy concept, but hopefully these examples clarify for you. All right, so our first example. A diagram contains two rectangles. The scale factor for the rectangles are 2 to 3. The smaller rectangle has a perimeter of 60 centimeters. What is the perimeter of the larger rectangle? Okay, so important to always know what your scale factor is if you can. And it tells us right here the scale factor is 2 to 3. You can also write that as a fraction 2 over 3. Okay? It says now the smaller rectangle is a perimeter of 60 centimeters. What is the perimeter of the larger rectangle? Okay, so what that previous slide was trying to tell you is that the relation between their perimeters is going to be the same as the relationship between their scale factors. So we're going to go to a proportion here. And again, I've kind of gone over this in previous videos, but on this side is always your math fact. So in this area, our math fact's always going to be our scale factor if we can find it. So this is 2 over 3. Now you got to remember that this is the smaller rectangle, and this would be the larger rectangle. It tells us the smaller rectangle is a perimeter of 60, so the smaller has to go up top, and then we're wondering about the perimeter of the larger. So what I do then once I have this proportion is I just solve. So I don't, the key here is if you're dealing with perimeter, you don't have to adjust your scale factor at all. If you're dealing with your area, you're going to have to adjust that scale factor before you plug it in. And in future videos, you're going to look at surface area and volume, and same deal, you'd have to adjust your scale factor first. So if you're dealing with perimeter though, you do not need to adjust your scale factor. So getting back into this, I will cross multiply 2 times x, 3 times 60. So 2x equals 180, divide by 2, x equals 90, and that's 90 centimeters. So I know the perimeter of the larger rectangle is 90 centimeters. Now, you could have also had a shortcut, and some of you would have picked that out already. You might have asked yourself, okay, well, 2 times what gives you 60? Well, 2 times 30. And whatever you do the bottom or the top, as long as you do the same thing to the bottom, would work out, because these are equivalent fractions, right? There's an equal sign there. So I could have multiplied the bottom by 30 as well then and got 90. whatever you want to do, people. The proportion is great if you're not into determining your own logic, but if you can find your own shortcuts, by all means, use multiplication. That's awesome. Okay, example 2. Jasmine is making a kite from a 2 to 25 scale diagram. The area of the scale diagram is 20 centimeters squared. How much fabric will she need for her kite? Okay, so our scale factor, remember our scale factor is our comparison between those two measurements. Now it does say it's talking about a scale diagram and all this stuff, but this is the same units because it doesn't mention that they're different units. So it'll either say something like this. If it said 2 centimeters to 25 meters, okay, then that would not be a scale factor. Not a scale factor in that one, okay? But in this one, because they don't mention the units, that's also my scale factor. So 2 over 25. Okay, so that's just a fraction. That's okay. Now we're dealing with, it says the area of the scale diagram is 20 centimeters squared. How much fabric would she need? So fabric, if you're wondering how much fabric you need, you're kind of wondering how much area you have to cover. So if that is the case, what we have to do is we need to square our scale factor. So we're looking at what is 2 squared and what is 25 squared. Then you get 4 over 625. So you always need to square your scale factor before you plug it into your proportion. So now I can use this in my proportion. Oops. 4 over 625. And we have to kind of read here. The area of the scale diagram is 20 centimeters squared. So the diagram would obviously be the smaller one. The kite would be the larger thing. So there's our 20 would go on the top. And then again, x is on the bottom. That's two examples in a row where x is on the bottom. It's not always on the bottom. It can be in top or bottom. And then I multiply. So 4 times x equals 20 times 625. So 4x equals, that is 12,500. Then I have to divide both sides by 4 to get the x by itself. And x equals 3,125. And then you got to remember your units. So that's why it's nice to write your units when you can. And I didn't write them up here, but I could have wrote centimeters squared. And because we already determined up here that they're the same units, then I know that that has to be centimeters squared as well. So this would have been centimeters squared. We're dealing with area, so that's why it's squared, right? So I just was trying to see what other measurement, though, centimeters, millimeters, or whatever we were using. So there we go again. And this is all based off that chart that if you know the scale factor, that the area, the way their areas relate to each other is you simply square that, all right? So that's example 2. Let's look at example 3. Okay, let's look at our final example, example 3. A trapezoid has an area of 49 centimeters squared. An image of the trapezoid has an area of 25 centimeters squared. Determine the scale factor used for the image. Okay, so when we're trying to find the scale factor, we're trying to find two corresponding kind of parts. Usually it's like a length or a width, but in this case, it's their areas, that we know the areas already, so we can use those to compare. Now, it wants the scale factor used for the image, so we got to make sure we put the image dimension or image value in that numerator, the top position, because the scale factor always describes whatever's in that top position. So if I have my fraction here, that was a bad fraction line, but I'm going to make sure I put the 25 up top, and that means the 49 goes in the bottom. Now, hopefully you remember from that chart that when we're dealing with scale factor, if we're dealing with the perimeter, then it's just whatever your scale factor is, and then the relationship between those perimeters are the same thing. But if we're dealing with the scale factor of the areas, that we actually had to square the original scale factor. So that means this thing, if we're talking about areas, this is not the scale factor, this is the squared version of it. So we want to take the square root of this to actually find the scale factor, to go backwards. So this would be the scale factor squared. So again, like I said, to get out of squared, I have to square root what I'm dealing with. So now I just have my scale factor, and that's going to be, what's square root of 25? Well, first of all, if that looks kind of funny to you, just a reminder, you can apply the square root to just simply top and bottom. So if that looks a bit more easy to handle, Anyway, but square root of 25 is 5 and the square root of 49 is 7. So then I know the scale factor for this situation is actually 5 over 7. And I was able to use my area, but I had to take the square root of that area. So that's how you go from knowing your area, or in future maybe a surface area volume from future videos, and getting back to your scale factor. All right, so that's scale factor. Really, it works hand in hand with proportions most times, and that's what we're doing a lot in this video and on your assignment. If it makes sense, that's great. And if it doesn't make sense, make sure you talk to your teacher or get a hold of me. Have a great night, everybody.